Hi guys, welcome to another tutorial. In this tutorial, I'm going to show you how to develop a Python script to extract topographic elevations from a DEM for a given number of points. Now as you see over here, I have a DEM, and on top of that I have another layer of points which shows some locations of few stations. Over here I have 9 stations. So my objective is to extract the topographical elevations of these given stations. Now, for example, if I zoom into one of these stations, let's say station number 6, and if I were to sort of manually pick the pixel elevation, I can select the DEM over here, and over here you can see that the elevation value is 291 over here for station 6. And similarly, if I check a station with a higher altitude, such as the station number 1, you can see that the elevation is 2568. So rather than doing this kind of station by station inspection for a given number of stations, now this could be a list of stations maybe in a CSV file, or this could even be a shapefile with points in it. You can simply use a couple of libraries in Python and extract all of these and extract elevations for all of these stations using a small Python script. So let's go ahead to our IDE, Spider IDE, and get started with the tutorial. Alright, now I'm in my file explorer, and from here you can see that I have 2 items over here. The first item is the DEM, and the second item is the stations which I just showed you guys. So these are those 2 files, the station shapefile and the DEM raster. So over here I'm going to right click and then create a new script. I'm going to name this as extracting topographic elevations.py. Alright, to get started, first I'm going to import 2 libraries. The first library is going to be the geopandas library, and the second one is going to be the rasterio library. So geopandas library basically will be used in order to read in the shapefile, and the rasterio library will be used to sort of pick the elevation values, extract the elevation values from each and every cell which corresponds to each station that we have. So let's go ahead and import those 2 libraries. Alright, so the first thing I'm going to do is I'm going to read the shapefile. We can do that simply by creating a variable called, let's say, stations, and that's going to be equal to gpd.readFile. And in here we have to specify the path to the place where you have saved your DEM. In this case, I'm going to just copy this path, and stations.shp, which is basically the file name of the shapefile name of the station's shapefile. Alright, now let's go ahead and run this, and we can just do a quick check by typing stations over here, and that will return to us the geodata frame, which is the stations. Now over here you can see we have a geometry column, the special geometry column, and along with that we have the column which contains the names of the stations. And if you want to do a quick check of the type, you can say type and stations, and it'll show you that it's a geopandas geodata frame. So the next thing what I'm going to do is I'm going to iterate through each and every row, and I'm going to extract a couple of things. Now one of the things that I'm going to extract is simply the name of each station. Along with that, I'm also interested in extracting the latitude and the longitude information from each station, and for that we can simply use a for loop. We can say for index and row in stations dot iteros, and during this iteration the things that I'm going to obtain are the names of each station, and also I'm going to obtain the latitude and the longitude. Alright, now you can obtain the name simply by picking the row, and you have to specify the column name over here. Now if this is not clear, let me just go ahead and comment this out for a second, and if I just say print row, you will see that during each iteration it's basically printing out the things along each row. So when you need to pick a specific things, let's say you don't need to print just the whole row, but then you need to print the name, which is basically the column name over here. And if you do that, you will see that it's actually printing out each and every name. Alright, so that's straightforward. So what we can do is we can get rid of this and we can activate these parts, and over here the name will be saved simply using name equals row, and we select the name column over here. And if you want to pick the latitude and the longitude, now it might be a bit tricky. Now if I come back over here and then check row, if I say geometry, because there was one column called geometry over here, and now if I say row within brackets geometry, it's actually going to give me the geometry elements which corresponds to the final station that it read during the iteration. And if you want to extract the x and y coordinates of this geometry, what you can do is you can simply say x, or you can simply say y. So over here you can see that by x it gives us the longitude, and by y it gives us the latitude. Alright, so the latitude, I'm going to simply copy this and paste it over here, and for x I'm going to simply copy it and paste it over here. Alright, maybe we can also add a comment saying that extracting attributes from the station's shapefile. Now as I explained to you, these attributes are basically the name, the x and y coordinates. In the same iteration, I would also like to read in the DEM. So let me add a comment saying reading the DEM using rasterio. So let me go ahead and create maybe a variable called, I'm just going to call it as DEM, and that's going to be equal to rasterio.open. Similar to the way that we specified the location for the shapefile over here, we can also specify the path for the DEM now. As you remember, it's still saved in the same location, so I'm just going to only go ahead and change this part, which now happens to be dem.tif, which is this file. And let's go ahead and run this and see whether we get any issues or not. Yeah, we don't have any issues. We can even do a quick check DEM over here, and you can see that the data has already been loaded into this DEM variable. Alright, so the next thing that I'm going to do is I'm going to pick the row and the column values from the DEM which corresponds to this each latitude and longitude that it recorded during each iteration. Now if I switch back to QGIS and if I zoom in over here, you can see that if you keep zooming in, you will eventually start seeing the pixels. So because this DEM is basically comprised of a number of pixels, and if you just look at this raster in a way, you can even look at it as sort of a matrix, because it's made out of rows and columns. So in the next step, what I'm going to do is, let's say for example during the iteration which corresponds to station number 5, I'm going to pick index which corresponds to row and column of this matrix or this array this station number 5 pixel belongs to. So we can do that simply by, we can create two variables. Let's say we can say row and column, which is equal to dem.index, because now we are interested in recording the indexes, and over here we are going to record the indexes corresponding to longitude, which is the variable that comes from here, and latitude, which is the variable that comes in here. So if I go back to the variables explorer and if I show you the longitude and latitude, you can see that during the last iteration it was recording these two longitude and latitude values. So spatially what it will do is it will go to this longitude and latitude and it will try to figure out in this array or in this matrix of raster pixels which the pixel which corresponds to that particular station belongs to. So if I run this, and now if I go to the variables explorer, you can see that this last station, which is station 9, which has the latitude and longitude values like these, are located in row number 1084 and column number 5767. So this will be done for each row and column, and then finally we can add a variable called DEM data, and that's going to be equal to dem.read. Alright, so what we can do now is we can program the script to do something like print. We can say the elevation of And now we can add maybe the name, because during each iteration it's going to have a different name, which is a string. And over here I leave one space, and from here I can pick the DEM data. And now what I'm going to do is I'm going to specify the corresponding row and column which it recorded over here. But there could be some issues, because what this will do is this will extract the elevation value, but if it's in float, then actually it's not going to get added to the rest of this statement, because these other parts are actually strings. So you have to convert this, even though it's a number, you have to convert this into a string so that it will get added to the rest of the statement. And we specify maybe the meters over here, the unit. Now what I can do is I can just run this script, and as you can see over here, it printed out that the elevation of station number 1 is 2570, station number 2 is 204. Like this, maybe we can do a quick check. If we go back to, let's go back to station number 9 and check whether it's 82 meters or not. Now station number 9 is located over here, and if I zoom in a bit, and over here you can see that the elevation value is 82. So this proves that our script worked without any issue. Now, instead of doing this, if you would like to sort of save this information into a specific CSV file, or do some further manipulations, maybe what you can do is you can use this same stations shapefile which you generated before. If I go to the Variables Explorer, and if I open this stations geodata frame, during each iteration, maybe what I can do is I can create one new column over here called elevations, and I can record each and every elevation which was extracted during this loop into that particular column. So that will be actually quite neat, so we don't have to worry about creating different pandas data frames or anything like that. So in order to do that, what I can do is I can maybe go over here and I can create an empty column for elevation values. Now, to create an empty column in a geopandas geodata frame, if you have worked with pandas data frames, it's actually the same way. You just specify the name of the column. In this case, it's going to be elevations, and for the time being I'm going to specify that to be 0. Alright, and now during each iteration I can, or maybe first I'll run this script. And if I show you now the stations geodata frame, you can see that we have one empty column called elevations. And at this stage, you can actually start recording values entries into those empty stations, entries. Alright, how you can do that is simply by saying stations, and over here we specify to which column that we are going to now record the values. And over here we have to specify the location. And the location can be picked based on this same index that we are sort of iterating through. Because during each iteration it will start, the index values will start increasing from 0, 1, 2 and all the way up. So that particular value will be included in here when I say index. And that's going to be equal to simply the same thing that we did over here. Alright, now if I run this script and if I go to stations, you can see that now the elevation values have been recorded over here. Then finally what we can do is we can save this maybe into a CSV or something like that. We can how do we do that? We can first extract the columns of our interest. Now you can see that we have got a couple of columns now. We have ID, name, geometry and elevations, but finally when we need the information, we don't actually need this geometry column or even this ID column. We just need the name and the elevations columns. So what we can do is we can say that elevations, which is a new variable, that's going to be equal to stations. Still we are in the geopandas geodata frame, but over here if I specify the names of the two columns which I need to extract the information of, and when I run this, and now if I say elevations, you can see that we only pick the two columns which were actually of interest to us. And one thing you should also know is that once you do this, you actually get rid of the geometry column in this elevations variable, which turns this from being a geopandas data frame into a pandas data frame. Because if you check now over here, the type of elevations, you can see that now it's a pandas data frame. Alright, so what we can do is we can simply go to elevations.toCSV, and over here we can specify the file name. Maybe I can say topographic elevations.csv. Alright, now if I save this and if I open the file which I've been working in, you will see that we have one file which got generated, the CSV file. And if I open that, you can see that now we have the topographic elevation values for each station. So basically this is what we wanted to do. So we extracted the topographic elevations from the DEM into a separate CSV file, and the benefit of having such a script like this would be that you can do this process for as many points as you want, and it's just going to take only a couple of seconds to do the whole process and basically extract a very nicely formatted bunch of information like this to you, rather than having to do the things manually. So I guess you guys learned something new in this tutorial, and if you did like the tutorial, don't forget to subscribe to this channel, and you can stay tuned for many interesting tutorials like this during the upcoming days. So take care guys, I'll see you in the next tutorial.